this presentation we are going to look at the Cauchy distribution. I hope I pronounced that correctly. It's a French surname, a very famous French mathematician. Anyway, we'll continue. The distribution of the Cauchy distribution is f of x equals 1 over pi times tan to the power of minus 1, so the inverse tan, of x minus mu divided by lambda plus 1 half. Okay, so here the arguments, parameters are essentially mu and lambda. Okay, now let x be the Cauchy random variable where mu is equal to 2 and lambda is equal to 4. Find the probability that x is less than 3, find the probability that x is greater than 4, and find the probability that x is between 1 and 3.5. So let's just actually go over the notes here. This is sort of like a body of knowledge, so to speak, okay, about the Cauchy distribution. Now you'll notice here I'm sort of deliberately not keeping the notation consistent, because this is what happens when you look at books. The notation is different from what your lecturer is doing or your course is doing to the book you're using. So that's just a fact of life, so let's just get used to that. So here mu is the location, and here in the notes in this formula here it is the x0, okay, and here the gamma, that's gamma there, that thing that looks like a y, I have it up here as lambda, okay, so it's lambda down there, okay. So we're using the cumulative distribution function, so essentially this is the one we're using mostly, almost exclusively actually in this instance. So 1 over pi times arctan of x minus x0 divided by gamma plus a half, okay. So just actually arctan there is just a different way of expressing the inverse tan of a function. And again, so just to be clear, I'm sort of labor on this point a lot, that the notation is not consistent. You have to get used to that. Okay. So in this case, what we're going to do is put in our values. So mu is equal to 2 and lambda is equal to 4 as given in the question. Okay. So we have 0.5 plus 1 over pi times tan of minus 1 divided time tan of minus 1 of x minus 2 divided by 4. Okay, so essentially what we have to do that is evaluate this. So it actually turns into a bit of calculator work actually. So the probability of x less than or equal to 3 is denoted here as f of 3. 0.5 plus 1 over pi times the arctan, tan to the minus 1 of 3 minus 2 divided by 4. So just a little bit of calculator work. 3 over 2 divided by 4 is 1 quarter. Get the inverse tan of that, 0.25. We divide that by pi. Also what we do is we add 0.5 to everything, and the answer should work out to be 0.578 approximately. Okay, so that's the answer to the first one. Part B, what's the probability that it's greater than 4? So essentially what we do here, probability is greater than 4, that is equal to the complement of probability of x less than or equal to 4, which is 1 minus f of 4. Okay, so same thing as before. Essentially what we do here, have 4 here, okay, 0.5 plus 1 over pi times tan of minus 1, the inverse tan of 2 divided by 4, 0.5, the inverse tan of 0.5 gives us 0.4636. We divide that by pi, and we add 1 half. So we get 0.3524 in this case. And finally, what's the probability of x being between 1 and 3? So essentially, very simple, probability of x being between 1 and 3. So we can evaluate that as f of 3 minus f of 1. Okay, so that is, put in that value again. The 0.5's cancel out, so we don't have to worry about that. And so 1 over pi times tan of minus 1 of a quarter, which you probably worked out previously in part A, and minus 1 over pi times tan of minus 1 of 0 minus 0.25. These actually work out that you get 0.25 and minus 0.25. So essentially what we do is end up with a plus. So that turns into a plus. And the answer works out to be 0.156. So that's it really. It's straightforward enough. The Cauchy distribution, when you're working with the cumulative distribution function anyway. A bit of calculator work, and that's it. Okay, we'll leave it there.